Hello everyone. Let's talk about acceleration. Acceleration is defined as the change in velocity per unit time, or it's also defined as the rate of change of velocity. Usually we know that these vehicles used to come with accelerators. So the vehicles are having accelerators to change the velocity. So without accelerator, vehicles we cannot give speed. So to calculate that acceleration, we are using this formula change in velocity. So delta V upon delta T. Or if you take V is the final velocity or U is initial velocity and T is the time taken. So V minus U upon T is also known as acceleration. Since velocity is a vector quantity, so acceleration is also a vector, and the SI unit of acceleration is meters per second square. So let us calculate acceleration. Suppose a car initially it is showing an accelerator. It is showing an acceleration initially at time t equal to 0. Its initial velocity on the meter is also 0. So I can take initial velocity is equal to 0. But if you can take at final velocity v equal to 100 kilometer per hour, so to reach the 100 kilometer per hour, it has taken time equal to, it is showing 11.26 seconds. Now here we need to calculate the acceleration of the car. We can use the formula acceleration A equal to final velocity minus initial velocity upon time taken. So here I can write that as t, or if you can mention this one as initial time t1, or this is final time t2, or you can write that as t2 minus t1. So like this also you can write it. So we are having the values final velocity and initial velocity and the final time and the initial time. So if you can substitute these values, acceleration equal to final here equal to 100 kilometer per hour minus initial equal to 0 upon time 11.26 minus 0. So whatever the calculation we get, so that is the acceleration of the car between 0 to 11 seconds. So let us understand acceleration much more. So the acceleration types. So acceleration is two types. One is uniform acceleration, another one is non-uniform acceleration. Uniform acceleration is defined as if an object travels in straight line and its velocity either increases or decreases by equal amounts in equal intervals of time. An object is moving in a straight line, either its velocity increases or decreases with equal intervals of time. So that acceleration we define as uniform acceleration. Example you can take, an object is falling under gravity. Due to gravity, if any object is falling, so that object motion, so that object is traveling with uniform acceleration. So coming to non-uniform. Non-uniform means velocity changes. Velocity of object is changing non-uniformly. Then the acceleration is known as non-uniform acceleration. So example for non-uniform acceleration, a car traveling in a straight road. So this is the example for non-uniform acceleration. So to calculate uniform acceleration, suppose I'm having graph between velocity versus time of an object is moving in a straight line. So this is the graph for uniform acceleration. Sorry, uniform velocity. Suppose if I calculate slope of this graph, suppose if I can take this at a point, the corresponding point of the y-axis along at here. Now if you can take the corresponding values on the x-axis, so this is representing the corresponding time, so this is t1 and this is the corresponding time t2, and similarly along on the y-axis, so this is the corresponding velocity v1 and here one more velocity, it is v2. So if I can mention, this is v1 initial velocity and this is v2 final velocity and the corresponding time t1. Now the slope of this curve, or we can write the acceleration formula a equal to, so this is change in velocity delta v, I can write that v2 minus v1, so delta v equal to, so delta v equal to v2 minus v1. So here delta t, change in time, which is also equal to t2 minus t1. So we are defining acceleration. So this acceleration we define as average acceleration. Acceleration average is equal to v2 minus v1 upon t2 minus t1, which also equal to delta v, sorry, here it is delta v on the numerator, so delta v upon delta t, change in velocity by change in time. Or if I can calculate the slope of velocity time graph of a uniform velocity graph gives acceleration. So if you can calculate the slope of the curve, so just like here you can calculate slope, so that we gives the acceleration. Or if you can able to calculate here the value of theta or tan theta, so here tan theta equal to acceleration, or tan theta is also the slope of the curve. Suppose to calculate for the non-uniform graph, suppose if you can take a non-uniform velocity graph. Now this is one of the non-uniform velocity graph. So to calculate the acceleration, here I need to divide this non-uniform graph into corresponding segments. Suppose if I can calculate the acceleration in this part, average acceleration between 0 to 10 seconds. So I need that acceleration between average acceleration equal to v2 minus v1 upon t2 minus t1. So here the v2 value, if you can take the corresponding value at here, so this value is around 24 meter per second. And what is the v1? v1 is the starting value here equal to 0. Therefore I can get that at here v2 equal to 24 minus v1 equal to 0 upon t2 equal to 10 seconds and t1 equal to 0. So 10 minus 0. So here I can get 2.4 meter per second square is the acceleration between 0 to 10 seconds. Suppose I would like to find the acceleration between 10 to 18 seconds. Now average acceleration between 10 to 18 second. Now here also you can substitute the same formula, v2 minus v1 upon t2 minus t1. But here you can see the graph is constant in this portion. So in this portion the graph is constant. So the final velocity value and initial velocity value, they both are the same. They both are touching at 24. So here 24 minus 24 upon 18 minus 10, which gives the value 0. Because the graph at here showing us flat equal to 0. The slope of the curve gives the 0. Now the average acceleration between 18 to 20 second. So this is for 10 to 18 seconds. Now here it is the final segment 18 to 20 seconds. So I need to find the acceleration in this given segment. So to find out the acceleration in the given segment at here, we can substitute same formula. So average acceleration A bar equal to v2 minus v1 upon t2 minus t1. Now here if you can closely observe, so this is my initial velocity v1, and at here since the graph is falling downwards, the curve is downwards, so starting is v1 and this is v2. So here final velocity v2 equal to 0 and initial velocity v1 equal to 24 meter per second, and the time here equal to t2 equal to 20 second and t1 equal to 18 second. So if you simplify this, average acceleration A bar equal to minus 24 upon 2 meter per second square. So here you can get that value minus 12, acceleration A equal to minus 12 meter per second square. So from this concept we understood that acceleration will be negative or acceleration also will be 0. Here we got the acceleration equal to 0 and acceleration is positive. So if the velocity is positive, if velocity of an object is moving forward, by the time the acceleration also will be positive. And if the velocity is constant, so in the graph the velocity shows in this region constant velocity. So in this region the velocity is constant. So if the velocity is constant, acceleration equal to 0. And if the velocity is decreasing, then acceleration will becomes negative. So in this region the acceleration is negative acceleration. Okay, so this is how we define average acceleration. But for instantaneous acceleration, so for instantaneous accelerations we define as, that is, limit delta t tends to 0. So we can write that change in velocity delta v upon delta t. So which is also we can write that acceleration A equal to the rate of change of velocity dv by dt. So instantaneous acceleration instantaneous, which equal to dv by dt, the rate of change of velocity. Since velocity v equal to the rate of change of displacement dx by dt. So we can write that instantaneous acceleration equal to d by dt of dx by dt, which also equal to d square x upon dt square. So this we call as second order differentials. So the acceleration in terms of displacement and time, so this is the formula, and acceleration in terms of velocity of time dv by dt. So these two terms we will find the acceleration of instantaneous acceleration. So instantaneous acceleration a equal to dv by dt in terms of velocity and time, and instantaneous acceleration equal to d square x upon dt square in terms of displacement and time. So this is how we can find the instantaneous acceleration. Suppose if I can show the three graphs. So for a non-uniform motion, suppose this is the graph of non-uniform motion distance versus time. So this is the distance x versus t non-uniform motion graph. For non-uniform motion graphs, if you find the slope at each point by using differentiation. So to find the slope from there to at here in each point, so this will becomes as velocity versus time graph for non-uniform motion. This is also non-uniform motion. But likely, if you find the slope of velocity versus time graph, so this velocity versus time graph slope, and we can get that this is acceleration versus time graph. So everything is linked up. So once if we can carefully understand the position versus distance time graph for uniform motion and non-uniform motion, so we can easily to get understand the velocity versus time graph for uniform versus for uniform motion and non-uniform motion. Similarly, for the acceleration versus time graph also for uniform motion and non-uniform motion. So let's understand that with the help of stimulation, moving man stimulation. Suppose here if I give acceleration 1 meter per second, 1.0 meter per second, and if I can play, so it's a positive acceleration, the object will move positive. Now if I can play back slowly, if you can observe here the three graphs are present. The shape of the displacement versus time graph and the shape of the velocity versus time graph and the shape of the acceleration versus time graph. So for positive acceleration. Now the velocity versus time graph is uniformly increasing. And acceleration and the position versus time graph also, it is also uniformly increasing. Suppose if we can take from there, if we can give constant zero acceleration, acceleration is zero, the man is not moving. So everything is flat, there is no increasing curve. Now we can observe that the velocity of the moving man is 0, the graph going on 0, but the position is changing because the position is now at 8 meters. That's why the blue line is went up. It is touching at 8, but the acceleration is 0 since the object is not moving. Suppose if I make this negative acceleration, suppose if I give acceleration minus 0.5. Now let us observe the velocity and the displacement versus time graphs. Now since he is moving with a constant negative acceleration, he is moving with negative constant acceleration. So that's why the green line is negative since it is a minus. And here we can notice that the velocity is versus time graphs is in the negative axis, because now the moving man is moving in the negative x-axis. That's why the graph plots negative. And you notice that the curve shape, the curve shape of the displacement versus time graph. So this we will see in a clear sketch at here the diagram. So if the position versus time graph, if the position versus time graph, the curve is increasing, so we can say that the acceleration is positive. Similarly, if the position versus time graph, the curve is decreasing like that, so we can say that the acceleration is negative. So here the negative acceleration means maybe the displacement is also negative or the velocity is also negative. Yeah, acceleration depends upon the velocity, and the velocity is a vector, so it is also depends upon the both magnitude and direction. So in the both the cases it happens, but right now I am discussing only the position versus time graph. If the position versus time graph curve is increasing, then the acceleration is positive, and if the position versus time graph curve is decreasing, then acceleration versus is negative. And if the position versus time graph is just a straight line, it is not a curve, it is a straight line, so by the time you can say that acceleration equal to 0. Since acceleration is a vector, so it's positive and it's negative and it's 0. So by observing carefully the position versus time graph, so we can define very carefully the acceleration of the moving object, as like both in the cases of this velocity versus time graph. So here from the above velocity versus time graph, so from this velocity versus time graph, so we define the position versus time graph. So they both are interrelated. So how the velocities changes, the corresponding the area also gets changes in the acceleration versus time graph. So let us derive some equations of motions to understand much more about acceleration. Suppose if I take a uniform velocity graph. So this is the question. I can write that equations of motion motions by graphical method. Let us derive equations of motion by graphical method. So I will make this in another video lecture so that it do not be so long.